Okay, this video is going to cover mLs per hour. I want to make note that with mLs per hour, you may also hear people call this flow rate, or the problem call it flow rate, or program the pump. If you see any of these saying, it's just simply asking for mLs per hour. So with IV medications, we do things a little differently. So anything IV, you want to start off with volume over time, because the question's going to give you both. So for each of these problems, for the volume, I'm going to highlight yellow. For the time, I'm going to highlight green. So reading this first question, the provider orders 1,000 mLs of normal saline to infuse over 8 hours. What is the IV rate in mLs per hour? So we need to get to mLs per hour. That's what we're trying to get to here. We're going to start off with volume over time. And let me just say, volume is like mLs, liters, ounces. Actually, ounces can be volume also. So we're going to highlight our volume in yellow. So mLs. And we're going to highlight our time in green. The problem wants us to get to mLs per hour, like we said. So we're going to set this up as volume over time. So our volume is 1,000 mLs over 8 hours. So right now we have mLs over hours, which is exactly what we need. So there's no further conversion or dimensional analysis that needs to happen. This simply is just going to be 1,000 divided by 8, which should give you 125 mLs per hour. All right, the next one, we're going to add a step because, once again, we need volume over time. So the pharmacy sends 100 mLs of an IV piggyback. So IV equals volume over time to be infused over 30 minutes. What is the flow rate? Flow rate equals mLs per hour. So we need to get to mLs per hour. We know that. Oops, sorry. That's our goal here. Okay. So we're going to highlight our volume. Our volume is 100 mLs. We're going to highlight our time. Our time is 30 minutes. So we set up volume over time, which is 100 mLs over 30 minutes. So we see here that we have mLs on top. So we're good here. Checks out. We need to get to hours. So we're in minutes right now. So a conversion you should have memorized is 60 minutes equals 1 hour. Therefore, to convert this, we know we need, because minutes is here, we're trying to cancel it and get to hours. Minutes has to go up here to cancel out. So 60 minutes here and then 1 hour. So this is going to turn into 100 times 60 over 30 times 1, which should give you 6,000 over 30, which is going to end up equaling 200 mLs per hour is your answer. This next one is the trickiest mLs per hour you'll probably have, because you have to set up two equations here. So we already said that in order to solve a problem, if it says program to the pump, it's mLs per hour. And you need volume over time. So let's read the problem. The nurse is caring for a client who requires a septic bolus. The bolus is 30 mLs per kilogram. Well, that's not really an accurate volume. It doesn't tell us exactly what the volume is. It's just 30 milliliters per kilogram over 2 hours. So our time is 2 hours. So we have our time, but we don't have an exact volume. And we know that the patient weighs 189 pounds. So the first thing we have to do is figure out what's our volume. So this is a weight-based problem that we have to set up like you previously have done. So we know we start with the weight. 189 pounds over 1. We're trying to get to kilograms. So we need to put pounds on the bottom to cancel out pounds and end up in kilograms. So we know that 2.2 pounds equals 1 kilogram. So we need to plug this in here. So the 2.2 is going to go down here, and the kilogram is going to go here. Now we need to get kilograms somehow to mLs. So we know that we can use this as a conversion, because pounds is canceled out and we need to cancel out kilograms. So we're going to put 1 kilogram on the bottom and 30 mLs on top, cancel out kilograms. And when we multiply this across, we're going to figure out how much volume we have. So this is going to turn into 189 times 1 times 30 over 1 times 2.2 times 1. So this should equal 189 times 30, which is going to give us 5,670 over 2.2. So our answer is 2,577 mLs. So now we can go back in and divide our volume by time. So this is the second part. Our volume is 2,577 mLs, and our time is 2 hours, and we're in mLs per hour. So we're just going to divide this, and you should get 1,288.5. Now, you should know that anything IV, because this is a decimal here, cannot be in decimals. We cannot use decimals to program our pump. So everything has to be a whole number. So because this is 5, it would tell us to round this to 9. So your answer should be 1,289 mLs per hour.